Hello guys, my name is Aditya Singh and today I'm going to solve the data science internal seconds questions. So in question number 1 we have in Bayes theorem probability of A upon B is equal to. So the answer is probability of A upon B is equal to probability of B upon A into probability of A in bracket upon probability of B. So the second question is uh, the 68 minus 50 95 minus 99.7 rule describe the probability mass of the dash distribution. So the answer for this is normal distribution. So the 68 minus 95 minus 99.7 or empirical rule is valid only for normal distribution. It says that about 60% of observations lie within one standard deviation of the mean. The third question we have is the metric that measures uncertainty gained when replacing distribution A with B is called. So the answer is Kullback-Leibler divergence. KL divergence measures how one probability distribution diverges from one reference distribution. So the fourth question is ridge regression uses an L dash penalty while lasso uses an L dash penalty. So the ridge regression uses L2 penalty and lasso uses L1 penalty. In regularized regression, we add a penalty term to the loss function to control model complexity. So the fifth question is the model that performs well on training data but fails on unseen data suffers from. So the answer for this is overfitting. Overfitting occurs when a model learns noise and random fluctuations in the training data instead of underlying pattern. Sixth question. In logistic regression, coefficients are estimated using the dash likelihood function. So it's a maximum likelihood function. In logistic regression, we model the probability of a class using the logistic function. Seventh question. The hyperplane in 5VM that maximizes distance between classes is called the dash margin hyperplane. So it is maximal margin hyperplane. Support vector machines SVM aim to find a separating hyperplane between two classes. Among all possible separating hyperplanes, SVM chooses the one that maximizes the margin. Eighth question. In clustering, K means minimizes the within cluster sum of. So the answer is squares. K means clustering partitions data into K clusters by assigning each point to the nearest cluster center. Next is in PCA, the first principal component captures the maximum possible data variance. Principal component analysis, that is PCA, finds new axes such that the first component explains the maximum possible variance in the data. 10th question is CNNs are particularly effective for dash data while RNNs are suited for dash data. So for CNNs we have image or spatial data and in RNNs we have sequential or time series data. Explanation. Convolutional neural networks, that is CNNs, use convolutional filters to capture local spatial patterns, making them ideal for images and other grid-like data. Recurrent neural networks process inputs in sequence, maintaining a high hidden state that carries information from previous steps. Next question is in TensorFlow, the structure representing operation and dependencies is called a computational dash. So it is computational graph. In TensorFlow, uh, computations are presented as a graph. Nodes in the graph are operations. Edges carry tensors between operations. This computational graph enables efficient execution and optimization across CPUs and GPUs. Next question is Hadoop's fault tolerant distributed storage system is called. So the answer is HDFS, that is Hadoop distributed file system. SDFS is a distributed file system designed to store very large files across multiple machines. It breaks files into blocks and replicates these blocks across different nodes in the cluster. Next, we have a SQL query combining rows from multiple tables based on related columns using the dash clause. So the clause that we use is join clause. The join clause in SQL is used to combine rows from two or more tables based on a related column, such as foreign key referencing a primary key. The Python collection that ensures only unique elements is called a set. In Python, a set is an unordered collection of unique elements. When you add duplicate items to a set to duplicate, the duplicates are automatically removed. 15th question. Bootstrapping is a resampling method that samples dash replacement. So it is with replacement. Answer is with replacement. Explanation: bootstrapping is a statistical technique where we repeatedly draw samples from the original dataset with replacement to create many bootstrap samples. Compute probability. A fair die rolled twice. Probability that the sum is equal to 7 is. So the probability for it will be 6 by 36, that is 1 by 6. When two fair sided dice are rolled, there are 6 into 6, that is 36 possible ordered outcomes. The combinations that give a sum of 7 are as given below. There are 6 favorable outcomes, so the probability is 1 by 6. 17th question. For a binomial distribution in which n is equal to 10, p is equal to 0.5, expected value is. So the expected value will be n into p, that is 10 into 0.5, so the answer will be 5. 18th question we have, if r is equal to 0.8 and TSS is equal to 100, compute RSS. So in this we will have RSS is equal to 20, because in linear regression the coefficient of determination r square is defined as r square is equal to 1 minus RSS upon TSS, where TSS is the total sum of squared and RSS is the residual sum of squares. So the question number 19th, in linear regression gradient descent update rule for weight W is equal to. Gradient descent is an optimization algorithm that updates parameters in the opposite direction of the gradient of the loss junction J. Question number 20. For a normal distribution, what percent of data lies between -2 and +27? So the answer will be approximately 95.4% of the data. In a standard normal distribution, the empirical rule states that 68% of data lies within +1 sigma, about 95% within +2 sigma, and about 99.7% within +3 sigma. Question number 21. For k-fold cross validation with k is equal to 5, each iteration uses what percent of data for training? So the answer is 80% of the data for training. In five-fold cross validation, the data set is split into 5 equal sized parts. In each iteration, one fold is used as validation data and the remaining 4 folds are used as training data. Question number 22. Compute precision if TP is equal to 40, FP is equal to 10. So the formula for precision is TP upon TP plus FP is equal to 40 upon 40 plus 10. So after calculating we will get 0.8. So the precision measures how many of the predicted positive cases are actually positive. So the answer will be 0.8. Next question, if recall is equal to 0.8 and precision is equal to 0.4, what will be the F1 score? So the formula for F1 score is equal to 2 into precision into call upon precision plus call. So after calculating these values, we will get the answer 0.533. The F1 score is the harmonic mean of precision and recall and is useful when we want to balance between the two. A model gives TP is equal to 70, TN is equal to 80, FP is equal to 20 and FN is equal to 30. So what will be the accuracy? So the formula for accuracy that we have is Tp plus Tn upon Tp plus Tn plus Fp plus Fn. So after the calculations, we will get the answer 0.75. Accuracy is the proportion of total correct predictions among all predictions. Question number 25 is, for a Poisson distribution, expected value is equal to, so the expected value will be equal to 3. For a Poisson distribution with parameter lambda, both the mean and variance are equal to lambda. Therefore, if x is equal to Poisson, the expected number of occurrence given interval is 3. Question number 26 is, write Python code to compute mean of list A is equal to, so the array is given 2, 4, 6, 8 using NumPy. So first of all, we will import NumPy as np. Meanwhile, mean underscore value is equal to np dot mean and a in bracket. We first import NumPy, a numerical computing library. The function np.mean calculates the arithmetic mean of the array or list passed to it. So the question number 27 that we have is, convert list 1, 2, 3 to a NumPy array. So in this, NumPy arrays provide efficient storage and operations for numerical data. The function np.array converts a standard Python list into a NumPy array. This conversion we can perform vectorized operation as element-wise addition and multiplication. Question number 28. Create a data frame from dictionary using pandas. Pandas data frames are 2D labeled data structures comparable to tables in a database or Excel sheets. When we pass a dictionary of column names to lists into pd.dataframe, pandas create a data frame where keys become column headings and list become column data. Here column A will contain 1, 2 and column B will contain 3, 4. Question number 29th is, replace all missing values in data frame df with column mean. Missing values can cause errors in analysis and model training. This method df.mean computes the mean for each numerical column. Passing this to df.filna replaces NaN, that is missing values entries in each column with the column's mean. True updates of directly which is converted are called data cleaning pipelines. The question number 30 is, display first 5 rows of data frame df. The head function returns the first few rows of a data frame with the default being 5 rows. This is commonly used for a quick inspection of the dataset structure, column names and basic values. Question number 31, we have plot histogram of column height and data frame of using matplotlib. So the explanation for this is, a histogram represents the distribution of a numerical variable by grouping values into bins. Using plot.hist on df draws the histogram. Question number 32 is, apply one hot encoding to categorical column color in data frame df. One hot encoding converts categorical values into multiple binary columns, one for each category. pd.get dummies automatically detects unique categories in df and creates a new column for each. Example, color red, color blue, etc. Each row gets 1 in the column corresponding to its and 0 in the others. So the 33rd question is, compute correlation between two pandas columns x and y of data frame df. The correlation method, that is core on a pandas series, computes the Pearson correlation with another series by default. This coefficient ranges from -1 to +1 with 0 indicating no linear correlation. Question number 34 is, find unique elements in a list using Python set. A set in Python stores only unique elements, automatically removing duplicates from the input. By converting a list into a set, we obtain a collection of distinct elements present in the list. Question number 35 is add a new key value pair of pi is equal to 3.14 to dictionary D. So in Python, dictionaries map keys to values. Assigning a value to a new key either creates a new entry if the key does not exist or updates. Question number 36, we have create a DQ and append elements 1, 2, 3 using collections.dq. A DQ, double-ended queue, is a data structure that allows fast appends and pops from both ends. We import DQ from the cell model and create an empty DQ. Question number 36, we have pop smallest element from a min heap named heap using heap queue model. The heap queue module in Python provides functions to maintain a list as a minimum heap where the smallest element is always the root, removes and returns the smallest element, then readjusts the heap structure. Question number 38. Create a numpy array of zeros of shape 3, 3. The function np.zeros shape creates a new numpy array filled with zeros. Here the shape specifies a 3 into 3 matrix. Such zero arrays are often used as initial placeholders or for creating structures to be filled during computations. Convert column date of data frame df to date time type in pandas. Real world datasets often store dates as string. Converting them to a proper date time type enables powerful date time operations. The pd.to underscore date time function parses different date formats and converts them into pandas date time 64 d type. In question number 40, we have filter rows of data frame df where column score is greater than 50. In pandas, we can use a boolean condition inside square brackets to filter rows. The expression df score greater than 50 returns a boolean series that is true for rows where score js greater than 50. Question number 41, we have no single machine learning algorithm performs the best on possible problems, refers to the dash theorem. So the theorem we are talking in this question we are talking about in this question is no free lunch theorem, that is NFL theorem. The no free lunch theorem states that when averaged overall the possible problems, no learning algorithm outperforms any other. This implies there is no universally best algorithm. Performance depends on the specific structure and assumptions of the problem. Therefore, in practice, we must experiment and choose algorithms based on data characteristics and domain knowledge. So, the question number 42, the method that uses smaller training subsets repeatedly to estimate test error is called dash. So, the method is cross validation. Cross validation is a sampling method where the data set is split into multiple training and validation subsets. Next question we have, in k nearest neighbors knn, runtime grows approximately with O with the order of n dash, where n is number of points and d is the number of dimensions. So the time complexity will be order of n into d per query. For a naive implementation of knn, to classify or regress for a new query point, we need to compute its distance to all training points. Question number 34. The curse of dimensionality mainly affects algorithm that depends on dash matrix. So the answer is distance matrix. The curse of dimensionality refers to various problems that arise when working with data in high dimensional spaces. The question number 45, we have PCA transform correlated features into dash components. So we have uncorrelated, or we can say orthogonal components. PCA finds linear combinations of the original features that are mutually orthogonal. Question number 46 is the process of mapping words to numerical vectors in natural language processing is known a word dash. So it is word embeddings. In NLP, word embeddings represent words as dense vectors of real numbers in a continuous vector space. In question number 47, we have in a neutral network, randomly removing neurons and their connection during training is called dash. So it is called dropout. Dropout is a regularization technique used to reduce overfitting in neural networks. Question number 48 is Spark uses dash RDDs for fault tolerant distributed data storage and processing. So answer for this is resilient distributed data sets, which is RDDs. Question number 49 in Hadoop, YARNs stands for dash. So the answer is yet another resource negotiator. YARN is the resource management and job scheduling layer of Hadoop. The last question we have is the match the following. So the Manhattan distance is matched with L1 norm. So because if it's sum of absolute differences, Euclidean distance is matched with L2 norm. Pearson coefficient is cov xy upon sigma x into sigma y. Spearman coefficient is rank correlation. L1 regularization is shrinks coefficients to 0. And L2 regularization is matched with shrinks coefficients proportionally. Then bagging is matched with bootstrap aggregation. Boosting is matched with sequential correction of errors. Ridge regression uses L2 penalty, and lasso regression, as we know, uses L1 penalty. Thank you.